Good morning, pre-calc class. I hope you're enjoying your snow day. I'm just going to do a couple examples with you of assignment 2 so that you can see sort of what you need to be thinking about. But really, it's all the same information we talked about last class. So make sure you submit your homework for today to Schoology. Take a picture of what you did for 6 and 9 and submit that. And then when you finish this assignment, and you're not doing all of it, you're just doing some certain numbers, so I'll write them down for you. When you finish this, you can also submit that to Schoology by 8 a.m. Friday to count for your attendance. All right, and please excuse my scratchy voice. I'm getting a little bit of a cold. So the first part you're going to do is 1 through 8. And here you have 8 different graphs, so you don't need to worry about this at all. 8 different graphs, and you need to match each one of these equations with one of the graphs. And so there are 3 things that we really want to think about when doing this. Okay, one of the things that we need to recognize is the degree of the function. Then we also need to find the leading coefficient. These 2 things will help us determine the end behavior, so up or down arrows. And then finally we want to think about turning points, and that is from your degree. Okay, so let's focus on, number 4. So if I look at 2x cubed minus 3x plus 1, the degree of this function is the highest power that we see. When it's all multiplied out, it's just the highest power. So the degree of that function would be 3, because it's x cubed is the highest power. The leading coefficient is 2, so it's positive. So that tells me that the end behavior should be, and use your little chart we filled in last time, but it should be down on the left and up on the right. Oops, left-hand behavior, right-hand behavior. You don't have to make those little notes, you can just use the arrows if that helps you. And then turning points, if it's a degree 3, remember it can have one less than that for turning points. So a degree 3 can have 2 turning points. All these graphs shown will have the maximum amount of turning points they could have. So I'm looking for a cubic function. The end behavior is down on the left, up on the right, with 2 turning points. Well, that looks like f. Down on the left, up on the right, 2 turning points. So number 4 would be f. Okay, so see if you can finish 1 through 8 just like that. You don't necessarily have to write out the degree, leading coefficient, and behavior and turning points. If you can think about that in your head, that's totally fine. But do come up with the matching letters. Okay, so that's the first part. Now let's scroll down here and look at the second part. So for each of these problems, I've sort of changed the directions here just a tad. So I want you guys to find all the real zeros, determine the multiplicity of each, determine the end behavior of each, and then sketch the graph of each function. Okay, so don't fret, we're not doing all 27 to 42 just yet. We will probably eventually. And most of this is just to get you back in the swing of factoring, but the rest of it is similar to what you did last class. So let's take 35, okay? So we have t cubed minus 4t squared plus 4t. Okay, so the first thing it asked me to do is find all the real zeros by factoring. So let's factor this out. So when you see that you have a t, or a common variable in each of the terms, I'm going to start by factoring that out. So my first step would be t, and then t squared minus 4t plus 4 is what I have left. T was divisible by all those terms, so I factored it out as the greatest common factor. And then in parentheses, I can continue to factor that. So now that I have t squared minus 4t plus 4, I'm thinking what 2 numbers multiply to 4 and add to negative 4. Well, that would be negative 2 and negative 2. All right, and so to condense that, this would really be t times t minus 2 squared, right? So right here, this is where I'm going to get my 2 zeros. So from this one here, I'm going to get t is equal to 0. And because this factor only showed up once, it has a multiplicity of 1, which means it's going to cross over the x-axis. This guy here is going to give me a 0 of positive 2, so opposite sign of this. And that one shows up twice, so it has a multiplicity of 2, which means that it's going to bounce or be tangent to the graph at 2. Okay, so I've identified my factors, my zeros, the multiplicity, and the behavior of the graph at those zeros. And so now let's see if we can sketch the graph of this. With your graphs, I'm really not expecting perfection. I just want a basic sketch. Hopefully your lines can be straighter than mine. Okay, so, sorry, I'm having a hard time with this. I don't think that was any better. So at 0, our graph is going to pass through, and at 2, it's going to cross over. So 0 and then 2. Or sorry, at 2 it's going to bounce. And the degree of this function was 3. And it has a positive leading coefficient, so the end behavior is down on the left and up on the right. So when I go to graph this, we're going to cross over at 0, hit 2, and bounce back up, and make sure our end behavior matches what we had just said. Okay, so that's what I'm looking for. Again, I don't expect perfection out of these graphs, but I just want you guys to get the hang of what these zeros and what the multiplicities mean. So for problems, can you guys please try 27, 29, 33, 36, 39, and let's do 42. Okay, so 6 problems, 6 graphs. See what you can do with that, and then if you submit this to Schoology by 8 a.m. Friday, and we'll take a look at it in class. Thanks, guys. Please feel free to email me with questions.